Hi everyone, today we'll go over derivatives of exponential and logarithmic functions. Let's start with e to the x. Given f of x is e to the x, the derivative f prime of x is also e to the x. Let's try some examples. Number 1, f of x is 4e to the x, the derivative f prime of x will also be 4e to the x. 2, g of x equals 2e to the x plus 5x squared minus 6. The derivative g prime of x will be equal to 2e to the x. The 5x squared, remember to bring the power down, that becomes 10x. Minus 6 is a constant, and we know the derivative of a constant is 0. H of x is a little tricky. It says e to the x plus e to the fourth. When we take the derivative of e to the x, we still get e to the x. But e to the fourth is just a number, so it's a constant. We know the derivative of a constant is 0, so my derivative, h prime of x, is only e to the x. Our second rule today is given f of x equals b to the x, the derivative f prime of x is equal to b to the x times the natural log of b. So when we have e to the x, we just get e to the x. But if I have b to the x, I have to also attach the natural log of the base. Let's try that. Start with f of x equals 7 to the x. The derivative will be 7 to the x, and then we multiply by the natural log of 7. 2 says g of x is 9 to the x plus 5e to the x. G prime will start with 9 to the x times the natural log of 9, and then 5e to the x is 5e to the x. H of x says 4 to the x plus 1/2 to the x. It might help if you look at that as 4 to the x plus parentheses 1/2 to the x. Then when I take the derivative, I have 4 to the x, and then I take the natural log of 4, plus 1/2 to the x times the natural log of half. Let's look at some application and why we would want to know the derivative of an exponential function. So start with, the number of subscribers to a music streaming service can be modeled by the function m of t equals 20 times 1.5 to the t, where m of t is the number of subscribers in millions t years after 2018. So first we're going to find the number of subscribers in 2020. Pay attention to the fact that t is the number of years after 2018. 2020 would be t equals 2. m of 2 is 20 times 1.5 squared. I threw that in my calculator, I got 45. The second thing we're going to do is find the rate of change of subscribers in 2020. That means we're going to start by finding the derivative. So 20, I have 1.5 to the t, and then times the natural log of 1.5. Now we're going to plug 2 in. So I'll have 20 times 1.5 squared times the natural log of 1.5. This gives me 18.25. I'm going to round to 2 decimal places. Then the third thing says estimate the number of subscribers in 2021. Well, we know that in 2020 we had 45 subscribers, and then we found out how is the number of subscribers changing, and it's increasing by 18.25. So we want to write plus 18.25. This will give us 63.25. So the thought here is the rate of change, which is the derivative, tells us if it's increasing or decreasing and by about how much. Let's look at depreciation. The value of a crane can be modeled by the function v of t equals 525 times 0.72 to the t, where v of t is the value of the crane in thousands t years after it was purchased. We're going to find v prime of 1, v prime of 4, and interpret the results. So since both things are looking for derivatives, the first thing I would want to do is find the derivative. V prime of t will be 525 times 0.72 to the t times the natural log of 0.72. V prime of 1 will be 525 times 0.72 to the 1, and then times the natural log of 0.72. Again, I'm going to do 2 decimal places. I got negative 124.17. V prime of 4, I find 525 times 0.72 to the fourth times the natural log of 0.72. This gives me negative 46.35. Interpretation. V prime of 1 says that the value of the crane will decrease by negative $124.17 thousand between year 1 and year 2. Then V prime of 4 being negative 46.35 says the value of the crane decreases 46,000 or 46.35 thousand between year 4 and year 5. The reason it's decreasing more at the beginning and less later is because the crane is worth more at the beginning. So just like having a car, we see the biggest difference at the beginning, and as the value decreases, then the rate of change decreases as well. Let's switch our look and start looking at logarithms. We'll start with natural log. I have f of x is the natural log of x. The derivative, f prime of x, is 1 over x. Let's take some examples. I'm starting with f of x equals 3 times the natural log of x, the derivative. I will keep the 3. Natural log of x becomes 1 over x, and typically we're going to write this as 3 over x. G of x says natural log of x to the 6th. Now, if you notice, I only gave you this one rule so far, which was what happens to natural log. But we have a bunch of properties of natural logs, and the first one we're going to use is the power rule that says powers become coefficients. So I didn't take the derivative yet, I just rewrote the natural log. Now I can take the derivative, which is I hold on to the 6, ln becomes 1 over x, and just like the first one, I'm going to rewrite that as 6 over x. So really important with logs is to rewrite before you take the derivative. H of x says the natural log of the square root of x. Well, we want to think about the square root as being the 1/2 power, and we said, well, powers can become coefficients. Now when I take the derivative, h prime of x, I keep the 1/2. Natural log becomes 1 over x. Multiply across the top, 1 times 1 is 1, 2 times x is 2x. Let's do a little bit more with this. So here, f of x says the natural log of 5 times x. Again, we don't have a rule for 5 times x or k times x. We only have a rule for natural log of x. So let's split this up as to the natural log of 5 plus the natural log of x. So this is the product rule. It says when we multiply, we add. Natural log of 5 is a constant. When I take the derivative of the constant, I'm going to get 0. So my f prime of x, natural log of 5 is gone, ln of x becomes 1 over x. G of x, natural log of x to the 4th. There's that power again. Bring that power in the beginning. So I have 4 times the natural log of x. Now I'll take the derivative. So I hold on to the 4. Natural log of x is 1 over x. I get 4 over x. H of x says the natural log of 2 over x. Now we talked about when I multiply, I add. When I divide, I subtract. So let's rewrite that as the natural log of 2 minus the natural log of x. Natural log of 2 is a constant. So when I take the derivative, h prime of x, the natural log of 2 is gone. It's 0. I keep the negative sign in front of the natural log. I take the derivative of ln. I get 1 over x. So my derivative is negative 1 over x. Our final rule today says if I have the log base b of x, the derivative is 1 over x times the natural log of b. So let's try that. Let's start with f of x is the log base 4 of x, the derivative. I'll have 1 over x, and then the natural log of the base, which was 4. G of x says 7 times the log base 3 of x. Derivative, g prime of x. Hold on to that 7. Then I know the derivative of the log. I have 1 over x, and then I do the natural log of 3. You can rewrite that. We can put the 7 on top, x, natural log of 3, and the denominator. H of x, I have two things. I have 2 times the natural log of x plus the log base 2 of x. Let's start with the 2 natural log of x. Keep the 2. Natural log of x, the derivative is 1 over x. For the log base 2, I have 1 over, I put an x in the bottom, and then the natural log of 2. You should see this consistency that all of the logs start 1 over x. If it has a base, then I'm going to attach the base to it, the natural log of 2 in this case. And if it was ln, I don't have to do that. We can finish this up a little, just put the 2 on the top, so I have 2 over x plus 1 over x ln of 2. Now let's mix them up a little to make sure we understand when to do what. So this first one says f of x is 9e to the x minus log of x, the derivative. 9e to the x stays as 9e to the x, minus log. The log of x, I know I have to put 1 over x, but don't forget you need the natural log of the base. This base is understood to be 10. This is common log, so be careful with that one. It's a little tricky that every once in a while you don't see it, so you don't want to use it, but maybe write it in to help yourself remember it. Then g of x says 3 log base 7 of x plus 4 natural log of x. G prime of x equals, I know I have a fraction, x is going in the bottom, natural log of the base, which is 7. By now you should see the coefficients end up going on top, so we can save ourselves that step and just go ahead and put it in there. Plus, I have a 4, the 4 will go on the top, natural log of x becomes 1 over x, so I have x on the bottom. So that's it. 4 basic rules today. I think again you should write them down on a piece of paper, maybe keep everything handy so that you know what to do with it, and we're going to add more and just keep combining the ideas as we go.